Alright, so now we're talking about solving absolute value equations. So first we got to think, what does absolute value really mean? Okay, all it really means is it's just the distance from 0 on the number line. Okay, so that means basically make the result inside the absolute value positive. Alright, so if we have a number line, 3 is 3 units away. So the absolute value of 3 is 3. Negative 4 is 4 units away. So the absolute value of negative 4 is just a positive 4. Alright, that's what we mean by absolute value. So like if I plug a 3 into here, that gives me the absolute value of 3 minus 5 is negative 2. Now, absolute value of negative 2 is just a regular 2. And then 2 minus 7 is negative 5. So that would be the result there. Here, we're going to plug in a negative 3 for n and a positive 3 for t. So negative 3 minus 3 is a negative 6 in the absolute value. Alright, now we got just a number in there. Absolute value of negative 6 is 6. And that's the form we get 10. Alright, so just one more here. Here we have a negative 2, a negative 3, and a 3. So negative 3 plus 3 cancel each other out. So we have a negative absolute value of negative 2. Okay, well, this part, absolute value of negative 2 is just 2. And we still have the negative out front here. So that's negative 2 is your answer. Alright, so that's how the absolute values work, in case you forgot. Now, what does it mean to solve an absolute value equation? Alright, so if we know that 4, the absolute value of 4 is 4. Absolute value of negative 4 is 4. Alright, so let's think, what do variables really mean? Alright, a variable, like let's say x, we usually use x, you can use any letter or whatever, stands for any number. It can be any number, right? So x equals, it could be anything. As soon as we put it in an equation where there's numbers in there, like something like this, alright, now there's only one thing that x can be, right? What does x have to be? Clearly, x has to equal 3. That's the only thing you could ever plug in here to make it true. Alright, so as soon as we make an equation, there are one or sometimes multiple, but there's only certain things that x can be. So here we see that absolute value of 4 is 4. So in this equation, x could be a 4. That's one thing x is allowed to be to keep that equation true. In this equation, look, we got negative, absolute value of negative 4 equals 4. So we could plug in a negative 4 and that would keep it true. So with absolute value equations, there's always 2 answers. And I'm going to put a little asterisk there because there's one case when there's not, and I'm going to go over that in a later example. But you should always be looking for 2 answers with an absolute value equation. It's this idea here. Alright, so what we do is we split these into 2 equations. I'm going to forget about the absolute values, and I'm going to say x equals 4, and that's one answer, right? And then I'm going to take this same equation, and I'm going to make this side negative. So that gives me x equals negative 4. And I don't have to do any of the steps, so that's solved. So you're going to break this into 2 equations. One stays exactly the same, and one you make the whatever is not in the absolute value, whatever is outside of it has to be the opposite. So if it's positive, it's negative. That's basically just these steps. Alright, so we have to have 2 solutions. Wow, that was a really straight line. So you got to first get absolute value by itself. That's the first step. That may be done for you, it may not be. Then you split it into 2 equations. One is exactly as is. The other has the opposite of the side that's not in absolute value. Then you solve each equation. Alright, so here's a little example. It's already isolated. There's absolute value and there's nothing else outside it on this side. So I make 2 equations. 1 stays exactly as is. 2x plus 3 equals 7. And I lose the absolute values. Now, if whatever is inside here, it's a 2x plus 3, if this were to equal a negative 7, that would still be a true equation, right? Absolute value of negative 7 equals 7. So if this were to equal negative 7, that would be true as well. Okay, so just to keep it kind of clear, get rid of that. And so now we solve both equations. Minus 3. So I have 2x equals 4. So I have x equals 2. There's one answer that would work if I plugged it in. And then, now notice I do the exact same steps. So I have minus 3, and that gives me 2x equals negative 10. So notice I did a minus 3 here for my first step, and I did minus 3 here. Because this left side is always the same, you're always going to do the same steps. Because the right side is always opposite, you're going to get different results on the other side. So here, I was minusing 3 from a 7. Here, I'm minusing 3 from a negative 7. But notice I do the same steps. And here, my second step was to divide by 2. Right? Same step. But now I had a negative 10, so negative 10 divided by 2 is negative 5. Those are our two answers. Alright, so I went through on that one nice and slow. I'll do a few more examples so you can see some of the other things that can happen. So, is it already isolated? Yes. So we make our two equations. Very similar to what we just did. One's exactly the same. One, you keep the inside of the absolute values the same, but you make whatever's outside opposite. So opposite of 2 is negative 2. So now I add 4, and I'm solving this, and divide both sides by 2, and we get x equals 3 is our answer there. Add 4, same first step. Now I have 2x equals 2, so x has to be 1. Alright, if I don't draw out all these little steps, just pause it and make sure you understand why I get from here to here, right? Obviously I divided by 2. But if I explain it every time, it's going to take a lot longer. So here, look at step 1. We have to get the absolute value by itself, alright? So that we don't have it by itself yet. So you have to subtract the 3 over. Now the absolute value here is all by itself, and we have a 3 on the other side. And this is just x equals 3. And x equals the opposite of this, and there's no work to do. You just got the answer right there. Alright, here we have to add 2. It doesn't matter that our absolute value is on the right, we just still have to get it along. So I have 10 equals the absolute value of 5x. So now I take the whatever's in here, 5x, and I set it equal to 10. And then whatever's inside, set it equal to the opposite of 10. Right, so divide both sides by 2, and we get, divide both sides by 5, sorry, x equals 2, and then x equals negative 2. Alright, so here, the absolute value is not alone, there's something outside it, so I have to divide by a negative 2, divide the whole side, and that reduces the negative 2, and I just have absolute value of 5 plus x equals, now I'm going to do it to the other side, right, same thing to both sides, and that gives me absolute value is negative 7. Now remember how I said that absolute value is really a distance? Alright, so you can't have a negative distance, even though this is a negative 4, it's a positive 4 units away, it's just 4 units backwards. So when we're talking about distance, negative distance doesn't make sense. So if you have an absolute value set to a negative number, right there, there's no solution. If this was a positive 7, I'd set it equal to do my two equations thing. But since this is negative, there is no solution, right? That's what we say when there's no answer possible. Alright, so now here is your U-try, very similar problems. And if you have any questions, just jot them down on the sides or comments so you don't forget to talk about them next class. Alright?